thousands of years, we have looked up with envious eyes and wondered, could we live there? If we are ever to leave this planet and build a settlement on Mars, now is the time to do everything we can. We face numerous existential threats: asteroid impacts, climate change, pandemics, and nuclear war. A self-sustaining colony on Mars can ensure the survival of our species, even if catastrophic events render Earth uninhabitable. While Mars is currently inhospitable to life as we know it, there is evidence suggesting that liquid water may have existed on its surface in the past. Rover missions like NASA's Perseverance and the European Space Agency's ExoMars are equipped with instruments designed to search for signs of past microbial life. Discovering it would have profound implications for our understanding of the prevalence of life in the universe. Understanding the factors that make Mars habitable, or potentially habitable, can inform the design of future habitats and life support systems for human settlers. This includes studying the distribution of water ice, assessing potential sources of nutrients, and investigating the effects of radiation and low gravity on biological systems. The challenges of exploring and studying Mars drive innovation in robotics, instrumentation, and space exploration technology. For example, developing rovers capable of navigating Mars' rugged terrain and conducting scientific experiments in real time requires advancements in autonomy, mobility, and miniaturization. SpaceX stands out as the foremost company dedicated to accelerating the colonization of Mars. Their flagship initiative, the Starship Project, is singularly focused on advancing this mission, but they are not the only one. Genesis are looking to plant Earth vegetation on Mars' surface. Before any planting can begin, thorough scientific assessment and mapping of Mars' surface conditions will be necessary. Certain Earth plants are more resilient and adaptable to extreme environments than others. Scientists would select plant species capable of surviving in Mars' harsh conditions, including low atmospheric pressure, cold temperatures, and high radiation levels. Upon selection, the chosen plants will be carefully loaded onto compact spacecraft and distributed across multiple starships. Mission control at SpaceX will assume command, overseeing the journey to Mars and orchestrating the deployment of the spacecraft onto the Martian surface. Initially, the plants will be cultivated in the controlled environments of the spacecraft, providing greenhouse and hydroponic systems. These controlled environments will shield the plants from the harsh Martian conditions while providing them with the necessary nutrients, water, and protection from radiation. One of the key benefits of planting vegetation on Mars is their ability to produce oxygen through photosynthesis. As plants grow, they release oxygen as a byproduct, gradually increasing the oxygen content in the Martian atmosphere. This process would contribute to making Mars' atmosphere more breathable for future settlers. As plants grow and establish themselves on Mars, they can also modify local microclimates, creating pockets of increased humidity and temperature. These microclimates may be more conducive to supporting other forms of life, such as microbes and small animals. Planting Earth plants on Mars as part of a terraformation effort represents a bold and ambitious endeavor to transform the Martian environment and make it more suitable for human habitation. While many challenges remain, including technological hurdles and ethical considerations, this approach holds promise as a potential pathway toward making Mars a second home for humanity. As a species, we must do all we can to support those leaders and companies who are bold enough to take humanity down this new transformative path. Without a doubt, it is hard work, possibly the hardest work we've ever undertaken. But what will be the cost if we don't?